In this last video of stoichiometric calculations, we are going from mass all the way to mass. So we're going from mass of one substance to mass of another. So on your handout, this is from one end all the way to the complete other end. So this is the longest type of stoichiometric calculation that you would be asked to do. And in this example that we're going to work through, we're given 10.0 grams of H2, and we need to convert that to grams of H2O. And in order to do that, we first need to convert the mass of H2 into moles of H2. So we'll do that first using the molar mass. Then we'll convert moles of H2 to moles of H2O using the mole ratio from the balanced chemical equation. And then we'll convert moles of H2O into mass of H2O using its molar mass from the periodic table. So keep in mind, again, I say this all the time and in every video, in order to do these stoichiometric calculations, you must have a balanced chemical equation like we do here. So if it is not given to you in the problem, you need to write it yourself. You have to have these coefficients in front of each substance to know the relationship. Okay, so we're going to follow this and convert from mass of one thing to mass of another. All right, so to start out, as always, we will start with the number given to us, which is 10.0 grams of H2. And our first step is to convert the 10.0 grams of H2. We first need to convert this into moles of H2. And we're going to do this by using the molar mass from the periodic table. And to set up our units here, I know that grams of H2 is going to go in the bottom because those need to cancel. And what I want is moles. So we'll have moles of H2 in the top. And the relationship here is that 1 mole is going to be equal to its molar mass. So 1 mole is equal to the molar mass of H2. And maybe you know this one by now, but hydrogen has a mass of 1.01 grams. Since the formula is H2, we multiply this by 2, so we get 2.02 grams. So that is our first conversion factor, which is the molar mass of H2. So now, after we cancel our units, we have converted grams of H2 to moles of H2. So now we're here in our process. So now we have moles of H2. We then need to convert to moles of H2O using the mole ratio from the balanced chemical equation. So we're going to set up another conversion factor. And again, I can write in my units because I know what those need to be. Moles of H2 needs to go in the bottom because those need to cancel. And now I want moles of H2O because that's what we're trying to solve for. All right, so I have moles of H2O on top, moles of H2O on the bottom. The way we get these numbers is from the balanced chemical equation. All right, so we look to the balanced chemical equation. We find H2O is right here, and it tells us that there are 2 moles of H2O. Then we look to find H2, it's right here. We see that there are 2 moles of H2. And that is our mole ratio, right? Those 2's came from the balanced chemical equation. Now if we cancel our units, moles of H2 cancel. Now we have just converted from moles of H2 to moles of H2O. So now we're at this spot. Okay, so we need to go 1 more to convert to grams of H2O. So we're going to have 1 more conversion factor. And this conversion factor, we're using the relationship that 1 mole is equal to the molar mass. So this time it's going to be for H2O. So we know that 1 mole of H2O is equal to its molar mass. So we need to calculate the molar mass of H2O, use your periodic table, 2 times the mass of H, which is 1.01, plus the mass of O, which is 16.00. Type that into your calculator, or you already have it memorized. It is 18.02 grams. That is the molar mass of water. Okay, so now our moles of H2O cancel. Those units are gone. and we are left with grams of H2O, which is what the question was asking us for in the beginning. So now our setup is all complete. We just need to type this into the calculator. All right, so we'll start with the 10.0, and then every number in the top you multiply, every number in the bottom you divide. So we're going to divide by 2.02, and then the mole ratio is 2/2, so times 2 divided by 2, they cancel out. And then this top number, the molar mass of water, 18.02, it's in the top, so we need to multiply it, equals this number here. And according to our sig fig rules, we are limited to 3 sig figs. So we'll look at that number, and we get 89.2, because after that it's a 0, so that will keep it at the number at 2 rather than rounding up. So we're going to get 89.2 grams of H2O. And that is our final answer for this stoichiometry problem. All right, so just to review quickly here, using our cheat sheet, I'll put this up here. So we needed to convert from grams of H2 to grams of H2O. So we were going from mass of one thing to mass of the other. We first converted mass to moles of H2 by using the molar mass. That's where this number came from. Then, to get from moles of H2 to moles of H2O, we used the mole ratio from the balanced chemical equation. So those numbers came from the equation. Then we needed to convert moles of H2O to the mass of H2O using its molar mass. So that's where the 18.02 came from. Right? And the way we knew what to put on top and bottom was just based on the way the problem was set up using dimensional analysis. We need these units to cancel, so we set them up that way. Sig figs match the number given to us at the beginning. All right, so that is the most complicated type of stoichiometric calculation, a mass-to-mass problem.